Well, hello, everybody, and thank you very much for joining us today. Today, we have a great honor to welcome the principal researcher at Algorand Foundation, Hugo Krawczyk, who will be giving us a presentation on why Algorand. I want to welcome everybody here, both students in my class, members of the Gator Blockchain Club, everybody who is coming online, everybody who came through Algorand promotion as well. We have people from industry. We'll be having people joining us from here, from the starter space in Gainesville. So a lot of friends and family of Blockchain Lab. This is our first big event, and we're really excited to welcome Hugo today. As for the agenda, we'll be having the presentation first, which will be about 25-30 minutes with plenty of time for questions and answers. We'll be using this little thingy microphone. So when you want to ask a question, we'll toss you the microphone. And also people who are online, please use the Zoom chat to ask questions, and I will read them out loud for everybody. And then for those of you who are here in person, after the presentation, we'll have pizzas, we'll have a networking event literally right next door to this. And after that, the Gator Blockchain Club is going to have their own regular meeting, and they'll be talking about NFTs. So we have a full day today. We have some great guests. We have refreshments, networking, Gator Blockchain Club, super exciting. I don't want to take actually too much more of this time. Hugo, thank you very much for joining us today.
Okay, thank you very much, Marco, for inviting me to talk here. I'm really excited about this event and this relationship between you guys and Algorand. Marco asked me to introduce myself a little bit. So let me tell you, I'm a cryptographer. I've been working in cryptography for maybe too many years, both on the theoretical and applied aspects of cryptography in academia and industry, mostly as a researcher at IBM Research in New York. Since 2019, I'm with the Algorand Foundation. Me and my group were the first to join or start Algorand Foundation, and since I was the first to be onboarded, and I called myself employee number one. I feel lucky to have lived through the internet revolution of the 90s, when the commercial internet started, when the web was born, and this gave me an opportunity to influence the science and also the practice and standards of security and cryptography. And it is really when things start at the revolution times where you can have more impact than when technology is already matured and established. And it's really exciting to live on times of change, especially those that changed people's lives. And the reason I'm saying this is because I believe we are here again at such times, and that's why I am here. And here I mean here in Algorand, in the blockchain space, but also here in this talk, because I really want to use this as a way of motivating you to join this journey of blockchain. Doesn't matter what discipline you are involved with. There is something to do about blockchains and inventing many things that, again, hopefully will change people's lives for the good. So now really to the talk. What I'm going to do is a conceptual introduction to Algorand technology, very partial and very high level, but to give you a sense of how the basic things work and how do we get to reduce electricity consumption by a factor of 10 million times relative to Ethereum, 100 million times relative to Bitcoin, moving fees from $2 to $30 in Ethereum to 1/10 of a cent in Algorand per transaction. This is between 3 and 5 orders of magnitude, and confirmation time for transaction going from 5 minutes in Ethereum, 10 minutes in Bitcoin, to 4.5 seconds in Algorand. And how all this performance efficiency actually brings us to the main properties that we want from a blockchain: scalability, security, and decentralization. And everything that has to do with application and engineering details will be presented in the next talks by PG and Ras, so I will not get into that. So I guess that you all know what is a blockchain. Just a fast summary: it's a public ledger of transactional data. It's represented as a chain of blocks, and this is a representation that appears in many blocks replicated across a system of multiple nodes. There is always a set of rules that is defined in order to agree with what the next block is, since you need agreement on all the nodes in the network. That process is usually called consensus. And then the result is a publicly verifiable, open to everyone, transparent, and permissionless database that is also tamper-proof. What is written there cannot be modified now or in the future. The consensus part, which is how do you get to agree on a block, then there are many variants, many different protocols in different blockchains. But something that is mostly common to all of them is you have the network, you choose one of the nodes as a block proposer, and that block proposer propagates the chosen block to the network nodes. The networks check the block for correctness of the transactions and the fact that the proposer had the right to propose, and if everything verifies, then the blockchain is added to the network. Again, this is very structural and very little details, but this is enough for what I want to show now. So how does the Bitcoin work, the consensus in Bitcoin? Well, this was invented by Satoshi Nakamoto in an 8-page paper that I claim changed the world. There are many ideas in that 8-page paper. One of the main ones is how to choose a block proposer, and that uses a mechanism that I like to call reverse lottery. Why reverse lottery? Because in a regular lottery, you know, you get a ticket with a number, then the number is announced, and then there is a winner of the ticket. Here is a reverse. You first announce the number, the winning number, then you let people nodes work on producing the ticket that has that winning number. And so every participant creates its own ticket, and the first one to find the winning number, that's the winner. And in the context of a consensus, this is the party that has the right to propose the next block. Of course, it is crucial that once someone wins the lottery, that everyone else will be able to verify that or validate that this is the winning one. Just to give an idea of how this works, the challenge number, the one that you will have to hit with your ticket, winning ticket, is a number that has the form of some value. It's a 256-bit number. The first 236 are a given number that is known to everyone, and then it follows by, let's say, 20 zeros. Actually, it's more these days, but the winning number, the winning ticket, is the one that can present a value y that when it's hashed under a cryptographic hash function, usually SHA-256, when you hash y, you get back that winning number. Okay, so a winning ticket is the one that contains a number y, that when it's hashed, you get back to that number that was published previously. By the properties of hash functions, it takes 2 to the number of zeros hashes to find y, which means that in these days it takes more than 1 billion hashes to find y. Okay. Now, once y is found, then everyone can check with a single hash that this is the winning ticket. I show my winning ticket y, and anyone can hash that y, see that the result is what it's supposed to be, and that validates the fact that I am the block proposer. Okay, so it's a lot of work to find the y, but then it's easy to verify it. So I think this is a beautiful, almost perfect idea. It's really the foundation of this revolutionary invention of a decentralized permissionless payment system, for which Bitcoin was the first. But why almost perfect? Almost perfect because it's tremendously resource wasteful. As I said, it takes more than 1 billion hashes to find y. And this is only the beginning of the bad news. The truly bad news is that every node in the network is going to do that. Every node in the network is going to spend about 1 billion hashes trying to find y, and only one will find it, or maybe 2 or 3. And the rest of the work is just waste. The guy that puts the block gets some reward, but everyone else is doing nothing with all this wasted energy. And this is what is called a proof of work, this type of system. But in particular in Bitcoin, you probably have heard that electricity consumption is that equivalent of that of a medium-sized country like Sweden. So the question is, can we do better? Can we replace the heavy computation that every node needs to do in the network in order to win the lottery with a very light local computation? Is that possible? If we can do that, not only we are going to remove this energy waste, but we will add to decentralization, because now everyone will be able to participate without having to buy expensive hardware or build mining pools as you need to do in Bitcoin. Okay, so let's see how do we actually achieve, again, this dream of replacing heavy computation with very light computation. So this is an idea that comes from Silvio Micali, the founder of Algorand. He's also a Turing Award winner. Turing Award is usually called the Nobel of computer science. He invented some really marvelous concepts and algorithms, including zero knowledge proofs and verifiable random functions that I will show now how it is used in Algorand. So really beautiful stuff, and Algorand, the protocol, is also one of his beautiful creations. Anyway, from all of the things, what I'm going to use now is the notion of verifiable random function that will replace the hashing. And let me explain a little bit about these verifiable random functions, or VRFs, and how they are used in Algorand. So as in Bitcoin, in Algorand, each participant will also solve a puzzle to find the winning ticket. But in Algorand, as the puzzle will take a fraction of a millisecond to compute. Okay, so it's at the high level is the same approach, but we are replacing billions of hashes to something that can be computed in a fraction of a millisecond. And once someone wins the lottery, everyone can check who the winner is, then check the block that is being proposed, and if it's valid, it's added to the blockchain. This whole process is called the consensus, and the Algorand has its own consensus based on this idea of VRF. And this is what brings us in Algorand to have a consumption, as I said, of 100 million times less than Bitcoin, or 10 million times less than Ethereum. Okay, this use of VRFs that are very, very efficient, that allows us to get to this low energy consumption and low computation, low cost of computers to participate, etc. So I always say that the light bulb went off serious ahead, thinking about using VRF in this context, but this light bulb doesn't use electricity. Okay, that's why I cut the cord. Okay, so a little bit about how a VRF looks. Again, this will be very high level, not much math here. Still, let me say that each participant will have a private key and a public key related to the VRF. The private key is secret. The public key is known to everyone in the network. For any value Q, any input Q, a participant can compute the VRF with its own private key on the input Q, and the output is guaranteed to be a random value that is unpredictable by anyone, not even by the participant itself, who cannot bias the output. Okay, so the important thing is that the VRF gives out a random value that no one can predict, and the participant itself cannot bias. So that's one property. The other property is that if the participant comes and says, look, on input Q, the output of my VRF is R, everyone can check that that's the case, without needing the private key, only by knowing the public key. Okay? So everyone can use the public key to verify that the output of the VRF is what has been claimed by the participant. Now, so, and as I said, or I didn't say, I don't know, both operations, both creating, outputting, computing the VRF and verifying the VRF, both operations take a fraction of a millisecond to compute. Now, once we have this VRF algorithm, that's how, here's how we use the lottery in Algorand. So a public value Q is published. The whole blockchain knows about it. It changes with each block. There's also a public threshold value T that depends on the number of participants. And each participant in the node takes its own private key. It takes the value Q that was published, and it computes the VRF on these values. If the value that it gets, this random value, is thinking of it as a number, is less than the threshold T, that participant wins the right to choose the block. Okay, so no more billions of hashes, just one computation of your own VRF, one fraction of a millisecond. You check if it's less than T. If it's less than T, you go propagate, you choose the block, the transactions that go into the block, you propagate the block to the network, and that is the block that is going to be chosen. Okay, so at a high level, it's a similar approach than Nakamoto's, except that instead of the hash-based thing, we are now using the VRF with a much less waste of energy and resources. And because this is so fast and so efficient to compute these VRFs, then you can do it with a laptop, you can do it even with a mobile device, and it means that anyone can participate, and which adds a lot to the decentralization in comparison, say, these mining pools that basically govern the whole blockchain, in the case of Bitcoin. Okay, so this is great. Now, the easiness of participation actually has a downside, which is now everyone can participate. So there will be bad actors that will participate. They will do flooding. They will do denial of service. How is this resolved? It's resolved with this approach called proof of stake, which is not only Algorand's approach. Proof of stake is the basis of many other blockchains as well. In the proof of stake, now the probability to be chosen as a block proposer is proportional to your stake. The more stake you have, more probability is that you will be able to propose a block. How is this done in, and what does stake mean? Stake is the amount of tokens or coins that you have in that blockchain. In the case of Algorand, these coins are called algos. Now, if we go back to the way in which block proposals were chosen, remember that it has to do output a VRF, produce a VRF output that is less than some threshold T. What we do is that now we adjust the threshold T depending on the stake that the participant has. So if I have a lot of stake, I will have a large T. If I have a little stake, I will have a small T. So for the small stake, it will be harder to hit its small threshold, and for the guy with a lot of stake, it will be easier. And you get at the end that you are a block proposal with a probability that is directly proportional to your stake. And the general principle behind proof of stake is that the more skin on the game you have, the more you will care about the system integrity. Yeah? If you have invested more in this blockchain, then you will not want that blockchain to fail, to become insecure, and then you will be an honest participant. This is not always the case, but it's enough that there will be a majority of participants that will behave honestly. Now, once we got a proposal, we got a block. That block needs to be propagated through the window, through the network. But then everyone has to check that the block is correct. It has the right. The transactions in the block are valid. The proposal is valid, and we don't want everyone in the node having to do that. So the approach of Algorand is to choose at random, a small committee that will do these checks for everyone. And if there is enough of an honest majority, we know that also in that committee, we will have a majority of honest parties. And this random committee will make the final decision of whether that is the block that is going to be added to the chain. And how do we choose members of this random committee? Using also the same VRF mechanism. Okay, so basically the VRF is really the technical basis for the consensus, and also for all the many of the goodies that some I already mentioned and some I will mention now. One additional important property of Algorand is its confirmation time, which it takes 4.5 seconds against 5 to 60 minutes in Ethereum and Bitcoin. Now, what's confirmation time? Confirmation time is the time that passes from the moment in which you pay in Starbucks for your coffee and the moment in which the server in Starbucks gets a confirmation in its screen that your money was moved to Starbucks, okay? In the case of Algorand, it will take 4.5 seconds to get the confirmation. In the case of Bitcoin, 60 minutes. So if you like your coffee to be hot, it's better to use a network with low confirmation. And there are many elements in these protocols that take to this huge difference. But one of the main ones is that in proof of work in Ethereum and Bitcoin, there is this thing of side chains or soft forks, which means that at any given time, it may happen that there's more than one block that is a candidate as the next block, and some parties will see one block, some others will see another block. Eventually, they all will agree on a single blockchain. But the problem is that there's some blocks that you will have to withdraw. So basically, you will have to undo some of the validation of transaction in the blocks that are being undone. That never happens in Algorand. If a block was decided, that's it. It's put into the chain. There is no forks. It will not be undone, or transactions will be undone. And all of that takes 4.5 seconds for confirmation. And again, we can get into more details, of course, of what are the all components of these 4.5 seconds, but the fact of the VRF being so efficient is a big part of that. So summarizing some of the Algorand properties, some I mentioned, some I did not. It's scalable to billions of users because of the easiness of participation. Currently, we support 1,000 transactions per second. We are developing improvement to the technology that will take us to some 10,000 transactions per second. We have 4.5 seconds per creation of block. The fees in Algorand, I've mentioned that before, is it's a 1/1000th of an algo, which today means 1/10 of a cent. There are no soft forks, instant transaction finality. Because of the low energy consumptions, we are carbon neutral. You don't need a strong hardware to run nodes. And several things that I did not mention. We don't use stake delegation or binding or no minimum stake. That also helps for making it easier for everyone to participate. And then there is other elements of security, like security against partitioning, security against denial of service. And all of these, when you put it together, you get the three pillars, the three main properties of the blockchain, which is decentralization, security, and scalability, which are achieved in the Algorand blockchain. Okay, there is much more, of course, beyond consensus. Of course, all the applications that run on top of that. Algorand has a bunch of elements that are already built in as smart assets, as built-in utilities. And just to, of course, I had to put the NFT in bold, because now it's the thing that everyone talks about. NFTs can be anything from art to real estate to cows. And the reason I put the cow is because we have a very interesting project on Algorand from Argentina, where cattle producers issue an NFT for each one of the cows, which will record the life of the cow from its birth to its unfortunate death. Okay, and Algorand smart contracts. Algorand has its own virtual machine, its own language. You will hear about the things in the coming talks, and of course, the fascinating world of dApps that run on blockchains that I will not touch upon here. One thing about the technology team in Algorand, it's an amazing team. I am not a technology person, so I can say that they are amazing. Since the launch in June of 2019, there has been zero downtime. Okay, the block, every 4.5 seconds, a new block is generated and no downtime. Okay. My final remarks. I gave you all these goodies of Algorand. Many of them can be quantified, so we can talk, not just in abstract terms. But there is this element that I want to highlight here, which is the importance of simplicity and elegance in technology design. I found the Algorand consensus, the use of VRF, really as a very simple and elegant concept. Of course, then there is a lot of stuff to be done in order to put this into to work in the real world. But when you have the basis of your technology being simple and elegant, that helps understanding, analyzing. It helps building security around it, and a better foundation to grow and adapt to changes that, of course, in the case of blockchain, you need that very much. And I like to use the analogy of TCP/IP, which was created 50 years ago, with thinking about communicate a small number of machines that communicate. And 50 years later, it's still carrying the whole internet on its shoulders. So I think that when you look into these things, you need to also pay attention to this abstract and subjective notion of simplicity. And with this, I can go back to the beginning when, this call to action for you, everyone, for every age, but definitely the young people that, join the journey of blockchains with Algorand or without Algorand, but it's a amazing space. It really has the potential of making lives of people better. And it depends also on the applications of the way you will develop on top of blockchains. So, okay. Last thing, in the Algorand Foundation, one of our missions is to support the Algorand ecosystem, but we have a very strong focus on education and students. In particular, we like and we do support student clubs, student communities. It's a really priority for us, and therefore, if you have any ideas of things that you want to do, from organizing an event, teaching a class, learning about Algorand, developing whatever ideas you have related, in this case, yes, to Algorand, you can talk to us, and we will provide you with support in different ways, depending on what you need. Okay, so that's the end of the presentation, and now I'm scared to get your questions.
Thank you, Hugo. Again, can we get a round of applause?
Thank you, and if anyone have more specific questions for me, you can write me email hugo@algorand.foundation.